Good morning, ladies and gentlemen. Welcome back to the Extraordinary Technology Conference 2017. This morning, we're going to be hearing from a first-time presenter here. Cameron Rebigsol is going to be speaking on how classical physics can endorse quasar behaviors. Cameron is a retired electrical engineer and hails from Vancouver, Washington. He has a huge interest in astronomy, and he plunges into the mystery of astronomy to seek answers to the anomalies that mainstream science can't and has not solved at this point. So I would like you to give a warm welcome to Cameron Rebigsol.
Thank you very much, sir. Good morning, ladies and gentlemen. Thank you for giving me this honor and opportunity to meet all of you over here. And I am a retired electrical engineer, but actually my main interest is in astrophysics. It seemed to me that after I read so many articles, I gradually getting more and more puzzled by those explanations. So by putting all the theory together, and I try to put up my own opinion. So together, today, let's explore those mysteries. The number one mystery I would like to explore with you is about the quasar. As we know, quasar are some celestial object highly compacted with mass and energy. The energy of this quasar is so condensed and so high that, for example, one of them is called 3C273. If it is placed about 33 light years away from us, it still makes us feel as hot as our sun makes us feel. That's how powerful those quasars is. However, they are extremely remote from us. Besides highly compacted with mass and energy, they are also keep spinning. Since their temperature is so high, the material existing in the quasar can only exist in a state of plasma. It means that all the particles exist in that collection, material collection, is electron, proton, and neutron. They separate and fly all over lawlessly. So when it is given birth, it must also spinning in high rate too, because it is how we observe about them today. This is how the quasar looks and under the paint, the paint of some artist. We have no need to read that. But anyway, so when it's given birth, those material in the quasar spin in a high revolution rate. In this picture, I used the white dot represent proton, and the darker dot represent neutron. That is the initial day when it is given birth. Nowadays, after a certain time, the neutron cannot be so spread anymore because they have gravitational attraction between each other. Gradually, it sinks to the central region of the quasar, leaving the protons still flying at the outer skirt because all protons are positively charged, they repel each other. Spread out like a proton in such a wide area, but sinking to the central region in a smaller area. Principle of momentum conservation must make the neutron core. Now, they condense to a central region, I call them a core. Must spin at rate far higher than what the entire quasar spins. Since they condense to the central region, I am going to explore one fact we observe from neutron stars. All neutron stars are rapidly spinning magnetic body. The magnetic field, magnetic strength is very strong. I want to explore this fact for the explanation of the quasar. Since the quasar, since the neutron core is spinning, and it can spin either this way or this way. If we stand at the edge of the spinning disk of the quasar. If the neutron core spin, it means a magnetic cocoon wrapping around the quasar also spin. All the electrical charge in this moving magnetic field must be forced to move in a certain way. Let's suppose we are a positive charge in that spinning disk. And at the edge, we see the neutron core over here. How the moving direction of the positive charge will move to if we are forced to move it by a certain way. So we stretch our hand out, and these fingers are pointing against the moving magnetic field, and have the palm receiving the penetration of the magnetic flux lines. And then this thumb will point at the direction where the positive charge must go. So if the neutron core over here is moving it this way, we are facing the magnetic flux moving this way. If the north point or the north pole of the magnetic field is pointing that way. Now, as a positive charge, I have to be forced to move toward the neutron core. But I am not the only positive charge. There are trillions of positive charge. So when so many positive charge or proton are forced to go near the central region, all the positive charge constitute a very strong electrical field. All protons must expel each other. However, they cannot expel in a random direction. There's only one direction for them to escape. That is at the axis of the magnetic field. If it goes away from the magnetic field, the magnetic flux will force it to go back to the central region. So that's how the jet stream is created. Okay. Now we just mentioned that the central region of neutron core is erupted by all those positive charge. And the positive charge has to move along the magnetic axis. But there are two directions for the magnetic charge, for the electrical charge to be so expelled. That's why we have a pair of jet stream. All the jet stream, the particles in the jet stream are moving in the same direction. As a rule, when charged particles move in the same direction, they will move very closely. The higher the speed, the closer they will stay together for a long time. And here's another situation. What if the spinning core is spinning in the other direction? In that case, the particle charge will be determined by this rule again. The neutron core moving this way, it means the magnetic field moving this way, and that the palm receiving the penetration of the magnetic flux line, and then we are forced to move further and further away from the neutron core over here. If the positive charge moves this way, it means that the negative charge must move this way. Now, it's the electrons' turn to move closer to the neutron core. And then the jet stream will be constituted by the electrons. This is the equation showing what energy those electrical charge can have when they move as a along the jet stream. This is the energy term. Okay, come down here. B is a magnetic strength. We all say that it is strong. V is the relative speed between between the charge and the magnetic field. The neutron core can spin so high that possibly at the 400, 200, 300, 400 revolution per second. Because observation shows that some neutron star can even spin as high as 700 revolution per second. Besides that, it is said that the spinning disk of the quasar can be compatible to our solar system. The radius of our solar system can be 30 AU, astronomical unit. One astronomical unit is the distance between the sun to the earth. 30 AU means that the radius may be as far as where Neptune is. With that distance, 30 AU distance, and also the spinning rate of 400 revolution per second, matching that revolution, matching that angular velocity. The linear velocity for the electrical charge moving through that magnetic field is extremely high. Calculations show that even the speed of light is dwarfed by that speed. But of course, because of some special situation, the speed cannot be that high. But still, not surprised, is way over higher than speed of light. Of course, you may not believe me because relativity shows that nothing can move faster than speed of light. But I'll show you a little later how valid relativity claim can be. So it's with this phenomenal amount of charge, each particle is moving along the jet stream. Some of jet stream are observed to moving at speed called superluminal movement. When a quasar is observed having jet stream at that speed, is called blazar. However, some scientists come out saying that superluminal movement is impossible. It's only an illusion. Today, we would like to explore how valid relativity can be, whether it can have enough credibility to claim anything being illusion. special relativity start its derivation with this equation set. In this equation set, all the A's, A11, A12, all the way up to A44 are treated as unknown. And all the X's, X primes, C, C prime, T are treated as if they are known quantity. Obviously, with only 4 equations but 16 unknown, this equation set cannot be solved. In order to solve, sorry, a lot of equations. Some equation play. Well, it must be when I submitted the package, some of the PowerPoint plate get omitted without my notice. So here I have to do a lot of oral expression to explain the situation then. Big loss. Sorry. Okay. In order to solve this equation set, relativity introduced another 2 equations describing sphere. The sphere is occupied by the progression of speed, the propagation of speed of light, and we take that two equations and with many supplementary equations, relativity eventually boils down to this equation set. Let me find it. Okay. That's the equation set right after those plates that I said miss. But actually, it is the equation set. What does this equation set mean in picture? Okay. What it means is that an observer on the x-axis we see an x, prime x, moving to this direction. At the same time, a ray of light from the expanding circle also moving in the same direction as this x prime axis. On the negative side, then this observer also see that the ray of light moving that direction cover a bigger and bigger distance along the x prime axis. Okay. I will quote 2 equations from the original paper of the relativity published in 1905 by Albert Einstein. But because of the miss here, I cannot show you the equation, but I'll show you the same equation to you on the other plate. That's the equation quote from relativity. With this, this equation, we are going to calculate the distance covered by the ray of light along the x prime axis and get to this equation. This is this distance, or equivalent to RAB quoted from the Einstein's equation. We notice this minus sign. It means that this equation is used for the calculation when the rate of light and the axis are moving in the same direction. And then we have another equation quote from relativity. This equation, in this equation, RAB is equivalent to this R multiplied. This equation, the plus sign, is used for the calculation when the rate of light and the x-axis, x-prime axis are moving in the different direction. As to the time for the calculation, that observed on the x-axis use only the clock next to him. There will be no time comparison, no clock comparison between two axes. It's only one clock for the observed on the x-axis. So with the same time amount, for quoting this distance and this distance, we get t equal in both these equations at the measurement of the measurement of the observation on x-axis. So now we get to this equation set. This equation set further enable us to have this relationship. As to the observer on the x-prime axis, he is not moving with respect to his own frame. So he will see that light always cover the same distance on both directions. So to him, to the observer on the x-prime axis, he always have the relationship and further this. Now, we flip this equation in the other direction to get over here. This is the rest length quoted by the observer on the x-prime axis. We further multiply the same factor on both the numerator and the denominator of the, this relation and get over here. When we multiply the same factor on the numerator and the denominator, we retain the equality to go here. But over here, these R prime plus and R prime minus are corresponding to this two quantity here. But over here, it is the moving length seen by the X observer. So eventually, we will get to this relationship. From here, we quote this over here. But if this and 1 are equal, we have only one solution to make this equation whole, which is V equal to 0. It means that even if we give credit to relativity, no movement is the only result for relativity. If as soon as it moves, that V is not 0, this relationship cannot be a whole. Relativity cannot solve any problem regarding movement. However, the damage to relativity does not stop here. Okay. Let's see this equation again. This equation is the condensed equation set from the initial equation set plus the light sphere equation set. Okay, from this equation set, we have this equation. These equations suppose allow us to study the movement or the origin of the space, the initial system, X, Y, Z, with respect to the X prime axis. Now, the origin of the X, Y, Z system has a coordinate value of x equals 0. So I put the 0 over here to replace the x. From the previous derivation, we have v equal to 0. So we put a v equal to 0 over here. Every other equation just copy over here. But when we come to this equation set, we notice that x prime is equal to ct prime. That's what is allowed by relativity. So over here, we are going to put, with this relationship, we put the ct prime over here. On this side, it eventually comes to 0, so we put a 0 on this side. This equation means that whenever t prime is not 0, but it's more than reality, right? We cannot have time 0 all the time. If we have a 0 time instant now, here it's not 0 anymore. So whenever t prime is not 0, the speed of light, according to relativity derivation, has to be 0. Relativity depends on the assumption of speed of light for each derivation. After it finished its derivation, it also concluded, speed of light is not 0 and also at the limit of the speed in the universe. However, at the end of its derivation now, we see that relativity destroys its assumption as well destroying its conclusion. How much credit relativity still have? To my opinion, none. So at this point, relativity cannot judge that superluminal movement is an illusion. No, to me, superluminal movement should be a real deal. Nothing can say it's an illusion. On the contrary, to me, relativity introduced a lot of illusion to us, such as time dilation and distance contraction. For that conclusion made from me, I posted an award of $100,000 at my website asking people to remove my refutation. Time to time, I receive some email from people out there, you are unprofessional by posting monetary award in science debate. To them, I respond to them is, what is more professional than claiming this award with your argument to have my refutation removed? Whether leaving this $100,000 as a sour grape or sweet grape, it's up to you. My purpose for posting this award, it is not for personal fame. I do want to have some public interest, public attention, to have this historical mistake in science study for more than a century, to correct it, so that the future generation will not be tortured by this invalid theory, relativity. When I come to the presentation of the conference, I heard a lot of people having their theory depending on ether. Relativity is a theory standing there to block the acceptance of ether. But now I feel that relativity has no credibility. Whoever holding the confidence on the ether, please be bold. Nothing can remove your confidence on that. At least I have not found any theory that tells people either cannot be existing, cannot be real. I don't believe so. And okay. The next subject I want to explore is the corona's abnormal temperature. Corona is part of the sun. However, in the daily observation, we don't see it. We see it only when full eclipse happens. It is this region they call corona. The dark place is the sun, but is in the state of full eclipse. In the corona region, the temperature can be as high as 2 or 3 million degrees Kelvin. But in our daily observation, we only see the photosphere of the sun, which has only about 6 degrees of Kelvin. So some people would say temperature or thermal energy cannot be moved, so cannot be transported from a lower temperature area to a higher temperature area. They put up a lot of explanation, particularly the wave theory. However, they eventually found that the wave, no matter what type of wave, cannot deliver so much energy to this area. As we know, a sun has a strong magnetic field. It is enwrapped by a magnetic cocoon. So, if an observer happened to look at the magnetic flux of this magnetic body or in the sun, the cutaway view of his observation, we see all those magnetic flux wrapping around the sun like this. And if we make some plane, any plane, perpendicularly across this axis, we will see pictures like this. Each of this represents the magnetic flux line penetrating onto the plane. Now the purple area is the sun. Close to the sun, an area closer to the sun, the density of the magnetic flux are compact. But further away, those lines become thinner and thinner. If I don't use the magnetic flux line to each of this to represent the flux line, I use the color. The heavier blue color area means more flux line. The lighter color means area with thinner, fewer flux lines. The sun is a body of plasma of high temperature. When the sun's nuclear reaction happens, it will give a lot of dynamic energy to each particle. Statistically, each particle should receive equal amount of energy from that explosion. But with heavier mass, the particle may stay with the entire body of the sun more. However, with less mass, the particle will fly away from the sun. Okay? So fundamentally, we can say that the sun, the material body of the sun, has far more positive charge, like a proton. But electron, with less mass, has to fly away and enveloping the sun, constituting the atmosphere layer of the sun. But when the electron is ejected to move in the surrounding, it is forced to move around through a magnetic field again. So an electron at this point A, for example, when it is ejected, suppose it should be anyway, not suppose, it should be ejected perpendicularly to the surface of the sun. However, as soon as it is moving, it enters the magnetic field. It is forced to move on a curve with less and less curvature. Why should we say this? Again, we use this hand rule to judge the direction. Before, when I use this hand rule to judge the direction, I'm talking about the positive charge. Now, we are talking about the electron, so we have to use an opposite direction. Now, if the electron is moving, ejected in this way, the magnetic field will force it to move this way. So gradually, it moves like this, okay? So gradually, its movement seems more and more straight, along a straight line. However, at point B, eventually at point B, the electron loses all its energy of movement. But the electrical force, the positive force from the sun, now can draw it back. The direction of this electrical force is due center of the sun. So it comes back on a straight line. However, gradually it will encounter stronger and stronger magnetic force because this entire magnetic cocoon. So it will move along the curvature again. Okay? Of course, it will continue to move. It can be quite complicated. I just use the initial part to illustrate a point, that's all. But at this electron is not by itself. It has many neighbors. All the neighbors will move in a similar pattern. In the picture, I only present 5 of such electrons. And we can see how those paths are trespassing, crossing each other. It only means that all the 5 electrons, during their movement, must strike and collide at each other, forcing each other to dump, to give up, to unload a lot of energy. But as we know, these cannot be the only 5 electrons that we can see. We are talking about trillions of electrons surrounding the sun. Can we imagine what amount of energy those electrons will dump in the area surrounding the sun and constitute the layer called corona? So I'm not surprised anymore why at the surface we have only 6,000 degrees, but in the corona area we are having 2 million or 3 million degrees Kelvin. Okay, the next topic I would like to explore is called dark matter. I believe many of you or all of you have heard time to time the mainstream scientists saying that whatever the material, the mass we see visible to us constitute only 2 or 3 or up to 5%, the most, of the universe. Other than that, the universe, 95% of the material are dominated by dark matter. How does this dark matter come to their conception? I believe that it is through the observation of the celestial object movement about the Milky Way. And I think in the year 1920 or 1930, something like that, somebody found that the celestial object at the outer skirt of the Milky Way move at speed higher than what the Newtonian law predicted. To their conclusion, unless the Milky Way have more mass than we find, this higher speed is not warranted. But as observable mass, that's actually all we can see. Where is those matter coming from? So they will create a concept called dark matter. That matter we don't see. Besides dark matter, besides introducing dark matter to explain this phenomena, some people also propose to modify Newtonian gravitational law. Now we explore how necessary we have to have these two concepts to accommodate this observation. The concept one is dark matter, and the concept two is modify Newtonian gravitational law. Here we have two pictures. This picture over here, we have a point mass. Over here, we have a bar. Both this bar and this point mass, we call it gravity body, and they both have the same mass. Okay? In other words, this bar sometimes can be regarded as a point mass. At this picture, an object called A happened to fly by the vicinity of this bar. Same here, it fly by the vicinity of the point mass. The mass center of this bar and this point mass has the same distance from the flyby object. It's easy to know that to obtain the gravitational force between this point mass and the flyby object with Newtonian gravitational law. As to this bar, I break them into infinitesimal part and then apply Newtonian law to calculate the gravitational force between this flyby object and this bar. And the calculation shows that the gravitational force A received from this bar is larger, is stronger than the gravitational law it received from the point mass. Both results are obtained through the Newton's law, but this force is stronger in this situation. Should we use dark matter to explain this? So unnecessary, right? But Newton's law gives us an accurate calculation for the gravitational force here. In this picture, this and this are actually the same. I place this flying by object down here instead at this end. The reason I split them into two is that I calculate this part, the gravitational force, this part first, and then I calculate this half bar, and then put them all together. And then we get, in this situation, we get this result as the gravitational force received by the flyby object. I also use the Newtonian law to calculate the gravitational force the flyby object receives. In this situation, the gravitational force the A received is less than in this situation. Besides, I will call the force the flyby object received from the point mass as normal force, but the normal, I have a quotation mark. Okay, if A received less gravitational force here than the normal force, should we call this situation we found mass deficiency here? Because otherwise, over here, we have a concept of dark matter to indicate a stronger force here. Okay? So, through the calculation, I believe dark matter is further rejected. Because otherwise, they have to put up another concept as mass deficiency for this situation, why the gravitational force now is weaker. In this situation, in this picture, I further move the flyby object to the central division line of this bar. Newtonian gravitational law further finds that the force A received now is even weaker than the normal force here. Should we even say that, oh, the mass even further deficient? I don't think so. Mass is the same. For all those calculations I present in the previous few plates, you can find the detailed calculation in this website, hantoon.net, and then click on the dark matter menu bar. The calculation is fastidious, alhamdulillah, but principally is easy. Any of you should have an easy grab on all those calculations, no problem. The only problem is whether you have time. You cannot spend the time for that. Now, as a summary of the previous analysis, we would say this: if the flyby object survive the gravitational pull of this bar, it will have a certain angular momentum. It will, and when it moves away from the bar, the angular momentum remain the same. But with the same angular momentum, when it moved over here, it will receive a weaker gravitational pull from this bar. The angular momentum, the flyby object, so inherit from the position, will make it fly with exceedingly high speed, and then it will end up flying away. On the other hand, if the flyby object did not come to their position from this position, but from anywhere else, and when it flies to here, and with the proper angular momentum to survive the gravitational pull from this bar, and if it continues to fly with the same angular momentum, when it moves over here, the gravitational force is strong over here. It will not have enough centrifugal force to survive the pull of this bar. It will get sucked in by this bar. It is because of this analysis, I would like to assert that the Magellanic Cloud cannot be a satellite galaxy of our Milky Way galaxy. Between the Magellan Clouds and the Milky Way, they are one-time visitors. As soon as they see each other, and if they say bye-bye. As a matter of fact, observations show that the Magellan Clouds today at its position, it seems moving with speed higher than a satellite galaxy would require. So observation and calculation will show that Magellan Cloud cannot be a satellite galaxy of our Milky Way. They will eventually fly away from us. In this picture, I put a bar horizontally and vertically and constitute cross. At a flyby object, if in this position, will have a speed, a centrifugal force, centrifugal movement speed, 4-1. In case that the cross swing into a point mass, that this flyby object will have to have another speed we call V42 to survive the gravitational pull. Actually, this should be 4-2. My typo mistake, I'm sorry. And on this relationship, this should be V4-2. So in other words, in this situation, when A fly by the position, the gravitational pull from the cross and the normal force are about the same. So it's about equal. Okay? But keeping the same distance, but place the flyby object at the tip of this arm of the cross, it will, when it survives the gravitational pull of the cross, when it enters this region, it will have excessive momentum. So it will fly faster. But not too long later, when it moves over here, the gravitational pull from the cross becomes strong again. Okay? So gradually, when it moves around, it will have a slower speed, faster speed, slower speed, faster, slower, so on and so forth. Okay? In this situation, comparing this speed with the normal force of the cross, the speed has to be that much. In other words, the speed of A at this situation has to be 0.184 times higher than the normal force. So in this situation, we compare two more flyby objects. If a flyby object has a closer distance to the cross, it has to have a higher speed to survive the gravitational pull from the cross. So object C, closer to the cross, has to have even higher speed to survive the gravitational pull. Okay, if in order to have this flyby object to fly with a smoother speed around the cross, it means that if this flyby object can see the cross as if it is a point mass, the distance between the flyby object to the center of mass should be at least 2 times long as each of the arm of the cross. In other words, if we regard that Milky Way as a point mass for the flyby object speed to be considered, we should have a distance of 31 kpcs. It means about 100,000 light years. But actually, the observation so far done is only up to 17 kcps. It means about 50,000 light years. Okay? And so the actual, if we want to have satisfactory observation so that the object can be matching what the Newtonian law predict, we should make observation at this distance other than stop over here. Okay, since there's not much, oh, okay, a little further. Okay, if the cross is considered loose material, and then derivation from this field object will make us to imagine that material of the arm should fly like this. And if every arm is consistent of loose material, we eventually have a picture like this. And then we have some rotation arms of a galaxy. But as to how those spiral arm are constituted, I cordially invited you to visit my website, www.huntoon.net, because I don't have enough time to complete the rest of my presentation. And thank you very much. And if you have any question, please let me know.
Thank you very much.
Thank you
Cameron
very much.
Rebigsol.
Yeah.
Well, Cameron, I love the concept of the sun being a plasma phenomenon. Your understanding of the mathematics is profound. So, looks like we do have a question here.
Thank you.
Yes, sir. In your calculations for mass, you're only using the centroid of the mass without regard to density. Is that correct?
I'm sorry.
Okay. In your calculations for mass, you're only using the mean centroid without calculation for density, regardless of density, correct?
The density of what?
Okay, and your calculations for angular velocity with respect to A
you mean that the flyby
Yes.
object? I consider it as 1 point mass.
Just the mean centroid of
Yeah,
the mass?
yeah,
Okay.
yeah.
So that in all your angular velocity equations and relative to A, it's to the mean centroid, correct?
Yeah.
Okay. And then also, in your spiraling equations, we're assuming that there's a differential between the balance of G and relationship to the mass and the angular velocity, that the angular velocity is either in excess or reduced so that we have the spiral either inward or outward.
Yeah.
Okay, thank you.
Yeah, thank you.
I was wondering, with your calculation where c turns out to equal 0, do you think it might have turned out that way because at c the rate of time is 0? Einstein said as you approach the speed of light, time slows down. So I'm wondering if a photon indeed is not moving through time at all, and the rate of time is 0, and that's what your
Okay.
equation shows.
You use the conclusion from relativity to support your question, but on the other hand, I said relativity with its own derivation give us no credibility. So its conclusion can hardly use as a question. I'm sorry.
Okay, thanks.
Otherwise, we
Right. Huh.
All right, thank you very much, Cameron Rebigsol. All right, ladies and gentlemen, we'll be taking a short break, and we'll be back with...